हेलो डियर स्टूडेंट्स। आज का ये हमारा फोर्थ लेक्चर है ऑन टेंसर्स, राइट। तो इन प्रीवियस लेक्चर में हम डिस्कस्ड अबाउट द डॉट प्रोडक्ट बिटवीन द वेक्टर्स, हाउ यू कैन राइट a vector in component form, right? And similarly today we will discuss about if we have this relation between we have cylindrical and rectangular vectors. Rectangular coordinates you can write. We have that x equal to, that is rho cos theta, and y equal to z equal to. Okay, so this is how you can relate them. So Cartesian coordinate is to cylindrical, these rectangular coordinates, and similarly we can have this spherical or so we can also relate these spherical and these rectangular coordinates by these relation as x equal to, that is rho, or you can write this as or sin theta cos phi. So this is how you can relate these spherical coordinates with these rectangular coordinates, right? Or you can write this as, so if you write this as, so this will be equal to, so if you plot this coordinate system, so suppose this is our x, y, and z, okay, and you can write this as, so we have this point z here. So this is our x and this is y, right? So this is our that rectangular coordinates and this is our z here, right? And similarly, we can also write this as, so we can have these cylindrical coordinates, so we can suppose this is our x and y, okay? Or you can write this as, so you can relate it like this, okay? So this is our that this is our phi, and this is our, okay? And similarly, so this is our z here, right? So this is the rectangular or the cylindrical coordinates, or even you can right now for this spherical coordinates. So this you can plot by, if you have this x, y, and z, x, y, and z. So we have some point at a distance of r, right? and this sort of phi, and this sort of theta. Okay. So these are the different coordinates. How you can relate this Cartesian coordinates with cylindrical coordinates or spherical coordinates, right? And you can see here this is theta and phi. So what are the basis vectors? So unit basis vectors here are. So the basis vectors here are. So that is r cap, theta cap, and phi cap. So ये हमारे unit basis vectors, right? And similarly for this one, if you write for the cylindrical, you can write there the unit basis vectors are. So that's equal to that's rho cap, phi cap. तो ये हमारे unit base vectors है in these cylindrical coordinates, right? And so these are for these unit base vectors for cylindrical, these spherical polar coordinates, right? And these are the relations how you can relate these Cartesian, these rectangular coordinates with cylindrical coordinates or spherical polar coordinates, right? So as I already showed from the diagram, so how you can write plot for the cylindrical coordinates. Now my question is, now if we rotate now our coordinate system, right? So that means the components of that unit vector will also change. Because if you make transformation from some Cartesian coordinates to cylindrical coordinates or from this cylindrical to spherical polar coordinates, the components of that vector change. But overall, you can say that the direction and the magnitude of that vector overall, so that remains invariant. So that hardly matters what kind of coordinate system you are choosing. Because if you make transformation from some rectangular to cylindrical coordinates, or if you अगर हम transformation करेंगे from cylindrical to spherical polar coordinates, so although the components will change, but total magnitude of that vector, because we can write that vector in terms of rho, phi, and z direction. Like we have that vector can be written as a of rho, a of phi, and a of z direction in cylindrical coordinates. Or that vector can be written in the spherical polar coordinates a of r plus a of theta plus a of phi, right? So overall, that total magnitude as well as the direction that remains invariant. Do a transformation from one frame to another frame. So that means you need to change the basis vectors, because basis vectors in different coordinate system are different. Because in cylindrical coordinates we have that rho, phi, and z, and similarly the unit basis vectors for these spherical polar coordinates are r, theta, and phi. Right? Now our question is, so in the previous lecture, so let me revise. So we have calculated that. If we calculate that, if we have the two vectors a dot b, so this I can write as, so that is equal to summation and starts from 1 to 3. That is okay. So this is what we have. So अगर आप ये पढ़ा होगा, if you have watched that video, so I have calculated that a dot b. If you take dot product between the vectors, so that's equal to this one, and this delta L is our canonical delta. So that's equal to 1. Right? So this is clear. Now instead of this, I can use this because so I can use it in the matrix form. I can write this as summation over n starts from 1 to 3. Right? And this GNM, it is that 100010001, right? So take as different values of, if n equal to m, so you can have these diagonal elements. So because we have, it's a so only the it has these non-zero elements on the diagonal, so rest will be 0, right? So that means if n equal to m, so we can get that only those components, that's ax with bx, so that's non-zero, but ax with by will be 0. And similarly we have that a by by and az and bz. So that means, so this is simply our that matrix having only the non-zero elements on the diagonal. So that 1 0 0 0 1 0 and 0 0 1. So that means our g of n will be equal to, okay. So this was what we have calculated in previous lecture. Now today's lecture is, so if we take now the cross product between the vectors. So that means if you write now, if we want to calculate now the cross product. So we have two vectors a cross b. So this I can write as, okay. So this is how we can write this as, or if you write this in component form, you can write that I into, so this is first component when you calculate that I, okay. And similarly that will be equal to, that's equal to, so let me check if I'm right. So this is when you take the kth component, that's ax by minus ay bx. So this is our third component, second and first component, right? Now, if you write now, so you want to define this the cross product, how to get these the different ith, jth, and kth components. So I uploaded only so this lecture in my YouTube. Now I will revise this. So we'll define some. We'll define here. We'll define. So we'll define here. That's called a real zeta sum, right? So that's our. So this is denoted by that epsilon ijk. Okay. So this epsilon ijk. So this is equal to 1 if we have that 1, 2, 3, 2, 3, 1. So that means if we have cyclic order. So that means if we have this is 1, 2, and तो अगर ये cyclic order follow करेगा, so that means 1, 2, 3 और 2, 3, 1 और 3, 1, 2. तो cyclic order में जो हमारा ये epsilon ijk, it is equal to 1, right? Now if it is equal to anti-cyclic order, so that means anti-cyclic means if we have 1, 3, 2, 1, 3, 2 or 3, 2, 1. So because I am saying that if it is that's equal to -1 if we have this 1, 3, 2 or 3, 2, 1. So in that case our epsilon ijk will be equal to 1. So it is clear because anti-cyclic means if it goes in the reverse direction, right? So like it goes like 1, 3, 2 or 3, 2, 1 or 2, 1, 3. So in all the cases when it is anti-cyclic, in that case our epsilon ijk it is equal to 1. Or there is one more possibility. So if there is a repetition of the indices. So repetition means it will be equal to 0 if we have 1 and 2, 1, 3, 3. So that means if there is repetition. अगर repetition होगा indices का, अगर हम 2 indices दो बार, एक indices दो बार लेंगे, like 1, 1, 2, 1, 3, 3 or 2, 3, 3. So in that case our epsilon ijk. So this is simply the notation. There's nothing great. Huh? This is purely mathematical symbol. In order to define our this cross product in terms of components, right? So this is very clear. Now let's write now. So if I am defining now, let us calculate now. ith component. तो इसका हम ith component अब calculate करेंगे. So that means a cross b of ith, right? So I can define that. Okay. So this I can write as, so this will be equal to okay, because so remember that so just check when we are calculating the ith component. So only when we calculating the ith component, only y and means second and third component of this a and b vector will survive, right? So because when we are calculating ith component, so we can have this ay, by, and either b z, right? So that means second and third component, y and z component, right? So that is why if you check that, so what I wrote here, if I calculate now a cross b of ith component, so that means इसके कौन से component होंगे मेरे j and k, because I will not be there. First component will be absent, right? So I can write this as, so this will be equal to summation. So that's equal to summation, or you can write this as okay, let me write it, or you can write this as okay. So you can write this as, so this will be equal to epsilon and there will be, so I forgot here to write this as, so this will be equal to So this will be equal to epsilon ijk ij. Right? So I forgot to introduce that. So this is epsilon ijk ajpk, right? And similarly, because when we are evaluating the ith component, first component, so we can have this components are that a and b. So we can have this j and k. So that means यहाँ पे possibility है j can be equal to 2 or j can be equal to 3 because it can be y component or it can be. So we can have y component of that a or we can have z component of a. And similarly for this b. So we can have by or we can have bz also, right? So this is very clear. So that means I can write this as it will be epsilon I 2 3 a2 b3. So this is first possibility. तो यहाँ पे मेरा क्या है? तो जो मेरा a है, I take that the yth component of that a. So that's I wrote here epsilon I 2 3 means our j is 2 and k is 3. And second possibility is that k can be equal to 2, j can be equal to 3. Right? So plus epsilon I 3 2 a3. So I think it is very clear, right? So because we can take both possibilities. यहाँ पे a का y component भी होगा, a का z component भी होगा, right? Similarly, b का z component for b का y component भी होगा. So that's why I take the both possibilities, right? Now if you check now, because epsilon, so check the property of this. So check the property of this Lewis-Sweeter symbol. तो ये कह रहा है कि so क्या possibility हो सकती है epsilon की? तो epsilon is as already we have that epsilon is that is epsilon I23 or epsilon 32. तो I can be +1 or -1 only when I equal to 1. तो अगर मैं I का वैल्यू यहाँ पे कितना, because I यहाँ पे 1 होगा then it has cyclic or it can have -1 value. अगर एंटी साइक्लिक ऑर्डर होगा और देयर विल बी 0 इफ देयर इज रिपीटिशन. तो अगर मैं यहाँ पे रिपीट करूंगा तो दैट मीन्स अगर यहाँ पे मैं लिखूंगा 3 2 3 सो दिस विल बी इक्वल टू 0. Or if I put here 2 2 3, so that's also equal to 0. Right? Or if you put I equal to 3, so only possibility for this I, so it can be equal to 1. Because अगर मैं I का वैल्यू 2 या I का वैल्यू 3 लूंगा तो in both the cases epsilon that I 3 2 or I 2 3 will be equal to 0. So that's very clear, right? So following the notation property of that Lewis-Sweeter symbol, right? So this will be equal to, so you can write this as, okay, so this will be equal to that epsilon 1 2 3 okay. So this is very clear. Now what's epsilon 1 2 3? So if you check that epsilon 1 2 3, so that is equal to 1 because it is cyclic, and 1 3 2 will be equal to, so 1 3 2 will be equal to, so that will be equal to -1, right? Because it is anti-cyclic, right? Because we have that this is 1 2 and 3, so we can have this. So this is cyclic. So because 1 2 3 will be equal to +1, right? And so 1 2 3 will be equal to +1. And if you take epsilon 1 3 2, so 1 3 2 means it is anti-cyclic. So anti-cyclic is the value -1, right? So that means this value will be equal to A2 B3 minus, because 1 3 2 will be -1, so that's A3 B2. So that means we can have that A cross B of I will be equal to, so that's equal to, that's A2 B3 means A by B Z. So this is, if you check that, so this is equal to this one. This one. So this is what we get here. A by B Z or A2 B3 minus A3 B2. So that means with the help of this Lewis-Sweeter symbol, we can also express the cross product between the vectors, right? Using that notation, and I will tell you the significance of that Levi-Strauss symbol in coming lectures when we need this, right? So for timing, you need to remember the notation and what is the property of that Levi-Strauss symbol, so that if you have clockwise rotation in indices, so cyclic order, so you can have plus one value, or if there is anti-cyclic order, so it will be minus one, or if there is repetition. So in case of repetition, that epsilon Ig will be equal to 0, right? And similarly, if you talk about now, let us calculate one more component. If we calculate now this A cross B of jth component, so that will be equal to summation j starts from 1 to 3, summation j starts from 1 to 3. Right? So this is very clear. Now, so which component we are evaluating? So we are evaluating the jth component. So jth component क्या होगा? So jth component you can check here. So when you calculate that jth component, that means x and z component will be present. Right? So this is very clear because when you are evaluating with respect to that j, right? When you are evaluating the jth component, only this x and this z component will be present. Right? So this is you can write them. So this will be equal to them. So you can have here. So this will be epsilon I, and this can be equal to 1 3 a1 b3 plus okay, because so don't remember that I means first component, right? So what I'm saying here, because I'm taking that I13, right? Because we are evaluating the jth component. So jth component में मेरा x और z present होगा, right? So this is what I wrote here 1 3. So 1 corresponds to x and 3 corresponds to z component, right? And so one possibility is that a can be a1 means ax, or it can be az. This can be az, here it can be bx, right? So that means both the possibilities. So that's what I wrote here, epsilon I31 and epsilon I32. So now, so following the property of that Lewis-Strauss symbol, so only possibility for this I, so it can be equal to 2. अगर मैं 1 लूंगा, so 1 1 3 will be 0, right? And similarly, I cannot put this 3 also, so it is 3 1 3 or 3 3 1. So in both the cases, our this epsilon ij will be equal to ijk will be equal to 0, right? So the only possibility for that I, it should be equal to 2, right? So that means I can write this as, so this will be epsilon 213 a1 b3 plus okay. So what is epsilon 213? So following that notation, if we have this is 1, 2, and 3. So if we have 2 1 3, so 2 1 3 is it is anticyclic, right? 2 1 3. So this epsilon 2 1 3 will be minus. So it will be minus a1 b3. So this will be equal to minus a1 b3. Okay? Because epsilon 2 1 3 will be minus 1, right? So because 2 1 3, so it is anticyclic. Okay? So anticyclic के लिए हमारा जो epsilon I1 Ij के it should be equal to minus 1, right? So that's minus a1 b3. And now 2 1 3, 2 3 1. So 2 3 1. So that's cyclic. So that means this will be plus 1. So you can have your plus a3 b1, right? Or you can write this as, so this will be equal to minus a1 b3 a3. So that's our J component, right? Or this is equal to, and one more thing I need to add here. So you can put that x on the subscript or superscript. So I will tell you maybe later when we need that. So how we why we represent, why we writing the indices in the subscript or superscript. So that is basically our contravariant covariant. But for timing, so you can put it in the subscript also. It simply indicates which component of that vector we are taking, right? So this is very clear. तो आप यहाँ पे भी लिख सकते हैं b of subscript of x, subscript of b, here you can put here x. So it doesn't have any specific property, right? So you can write b of subscript of x also, right? So there is nothing in it, right? So this is what we have calculated for this jth component, right? Similarly, you can calculate that. We can calculate that a cross b of jth component, right? So this we can check that. So it is value we can also calculate using the property of this Levi-Strauss symbol, right? And similarly, so in our coming lecture, so this lecture was very short. So in our coming lecture, so that will be very interesting. I think that will go interesting because we will discuss how these vectors transform. So if we go from one frame to another frame, so how these vectors transform, and we will discuss many more interesting things in coming lecture. Thank you very much.